Hello, this is VU Assessment 3. I'm solving problem 30 from chapter 3. In this problem, there's two stars given, and on both the stars, the mass, the initial velocity, and the initial position of both the stars are given. Like all the values which were given was on vector, so I changed them to scalar. So for the first star, the velocity was, the mass I just kept it. For the initial velocity was 7,6, -8 times 10 to the fourth. Then I took the magnitude of that velocity. Then I found that to be 1.2 times 10 to the fourth meters per second. With the initial position, I took the magnitude of that. Then I found the value to be 6.71 times 10 to the -12 meters. For the second star, I did the same thing, and I took the initial velocity of it, and I took the magnitude of it. Then I found out that to be 9.27 times 10 to the fourth meters per second. With the initial position of the second star, I did the same thing, took the magnitude of it, and it happened to be 6.64 times 10 to the 12th meter. The first part of the question is, at t is equal to 1 times 10 to the 5th second, what is the approximate momentum of the first star? To find that, I need to know the acceleration first. So to find the acceleration, I started from F is equal to ma, then I derived it, and I got it to be A is equal to the gravitational constant times the mass over r squared. The gravitational force in space is 6.71 times 10 to the -11, and the mass of the first star is 4 times 10 to the 38 kilograms, then over r square. R square we found here in the initial position, then I took that and I took a square root of it. Then after solving it, I got the answer to be 5.9 times 10 to the -6 meters per second square. After I found the acceleration, I tried to find the final velocity of it. To find the velocity, I just used the velocity update, which is nothing but v final is equal to the v initial plus acceleration change in time. So the initial velocity, which we found here, which I took that, and then the acceleration, which we found here, I plugged it in, and the change in time, which is 1.1 times 10 to the fifth minus 0, which is same thing. Then after solving that, I got the answer to be 1.2201 times 10 to the fourth meter per second. After I found the acceleration and the velocity, and I have all the things to find the momentum which was asked in the question. So momentum is nothing but P is equal to the mass times the velocity. So the mass of the star is 4 times 10 to the 38th, and the velocity, the final result which we found here, and the initial which we found here, I just took the difference of them both. After solving that, I got the answer to be 4 times 10 to the 38 kilograms meters per second. And that's the answer for part A. For part B, it asks us to discuss briefly some way in which your results we found on A is an approximate, not exact. Well, this value is an approximate because when calculating the gravitational force, we didn't consider all the other stars next to it. So the gravitational force from the other stars will affect the momentum of this. So it is not accurate. It is not an exact value. So for part C, it asks at t is equal to 1 times 10 to the 5th seconds, what is the approximate position of the first star? To find that, I just use the formula x is equal to v initial times time plus 1/2 acceleration times square. So the initial velocity of the first star we found here, I just plugged it in, and the t, the time which they're given, which I plugged it in, 1/2 acceleration, which we found here, I plugged it in, and time square, I just squared it. Then when I solved that equation, I got the answer to be 1.22003 times 10 to the fourth meters. Therefore, the position of the first star, that's the position of the first star. For part D, it says, discuss briefly some way in which the results you found at C is an approximate. It's like the same reason for part A, because we didn't consider the gravitational force to the remaining stars. So therefore, it will affect affect the position. So therefore, it's not